Here we are going to study now a part of trigonometry which is called triangle trigonometry, which is also known as properties of triangle. Let us consider a triangle ABC. It has three sides: BC denoted by small a, AC denoted by small b, and AB denoted by what? Small c. So BC is opposite to the vertex A, denoted by the corresponding small letter. AC is opposite to the vertex B, so it is denoted by corresponding small letter. AB side is opposite to the vertex C, denoted by corresponding small letter. Now we denote the angles at the vertices by the corresponding capital letters A, B and C. So I have 3 plus 3, 6 elements related to what? The triangle, 3 of which are sides and 3 of which are angles. So 3 sides plus 3 angles are called 6 elements of a triangle. If any 3 of them are known, we can know the triangle completely, except when angles of the triangle are known, we know the triangle in shape but not in the size. For example, if I consider a triangle ABC, which is an equilateral triangle, each angle is known to be 60 degrees. So I can draw infinitely many equilateral triangle of different sizes. So if all the 3 angles are known, we may or may not know the triangle completely. I mean, we know the triangle in terms of shape, not in size, whenever 3 angles are known. In all cases, we know the triangle completely. That is, if any 3 elements of 6 elements are known, we can find the remaining 3 elements of that triangle. That is called solving the triangle completely. Now to solve this, we are going to use trigonometry. There are trigonometric ratios, sine, cos, tan, sec, cosec, cot, which are helpful in finding these 3 sides and angles of the triangle. Let us try to establish some relation among the trigonometric ratios and the sides of the triangle with these angles. The very first rule is known as sine rule. The rule states that in a triangle ABC, small a divided by sine A is equal to B divided by sine B is equal to C upon sine C. So sides of the triangle are proportional to sines of the angles of the triangle. This proportionality is equal to 2r, where r is the circumradius of triangle ABC. That means I can draw one circle passing through the vertices of the triangle ABC, and if I take O as the center of this circle, which is called circumcenter of triangle ABC, then this OA, OB and OC are each equal to what? Capital R, which is the circumradius of triangle ABC. So sine rule is what? A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R, where R is circumradius. R is circumradius. Now how to establish this result? Let's see. Because this is a circle, this is the center of the circle, this angle is A, and this is the chord of the circle. So this chord BC subtends an angle A at the circumference, and this BC also subtends some angle BOC at the center of the circle. From the geometry, we know that the angle subtended by BC at the circumcenter is double that of the circumference. So if this is A, this must be double of A. Now what we do is, let us drop the perpendicular from the center of the circle on the chord. So this angle is twice A. So let me drop the perpendicular from this point O on the side BC at say M. Then these two triangles are very clearly congruent. And because this was twice A angle, angle BOC was twice A, therefore this angle becomes A, this angle also becomes A. Now if you look into this triangle BMO, in this triangle, now because M is the midpoint of BC, being dropped the perpendicular from the center of the circle on the chord, M is the midpoint of BC and total distance BC is A, therefore BM becomes A by 2, MC becomes A by 2. Now in this triangle, right angle triangle OMB, if I find sine A, I get sine A is equal to opposite side, that is A by 2, divided by the distance OB, which is the radius of the circle. So very clearly, sine A is A upon 2R. So by doing the cross multiplication, I get A upon sine A is equal to 2R. So similarly, I have proved that A upon sine A is equal to 2R. So by dropping the perpendicular from O on the side AC and from O on the side AB, I can establish the result B upon sine B is equal to 2R, C upon sine C is equal to 2R similarly. Hence, the result A upon sine A equal to B upon sine B equal to C upon sine C is equal to 2R is being proved. There are various proofs of this, but the one of the simplest proof that I have given to you of sine rule. So remember, A upon sine A is equal to B upon sine B is equal to C upon sine C equal to 2R. If I consider this 2R is equal to some constant A or K. So A upon sine A equal to K means A is equal to K sine A. Similarly, B is equal to K sine B. C is equal to K sine C, where K is the constant of proportionality. So we can always express sides small a, b, c in terms of sine A, sine B, sine C with some proportionality constant. Similarly, I can write sine A equal to AK. If I assume that this 2R is 1 by K, then sine A becomes AK, sine B becomes BK, sine C becomes CK. So while solving the problems of properties of triangle, we at many times we use this fundamental rule, that is A is equal to K sine A, B equal to K sine B, and C is equal to what? K sine C, etc. So remember this. So this rule is very important for us. The second rule that we will go about, which is called the cosine rule. So cosine rule is as follows. Cosine rule is given by cos A is equal to B square plus C square minus A square divided by 2BC, or cos B is equal to C square plus A square minus B square divided by 2CA, and cos C is equal to A square plus B square minus C square divided by twice AB. So in triangle ABC, if all the three sides are known, small ABC, we can find all its angles using the rule known as cosine rule. So cos A is given by this, cos B is given by this, cos C is given by this. So there is a sort of symmetry and one cyclic order by which you can easily remember the formula. When you write cos A, you begin with A, then you write afterward B, then C, and then A, divided by this 2BC down. Similarly, after BC comes, after CA comes, after AB comes. After CA comes, after AB comes, and after BC comes, divided by twice AB. Whichever two terms are there, so 2 times the product of the roots of this is written in the denominator. So this is what is called a cosine rule. Now one can write this rule as, if I do the cross multiplication, 2BC is brought to this side, and then 2BC cos A is brought to this side by bringing minus A square on this side. I always write A square as B square plus C square minus 2BC cos A. Similarly, I can write B square is equal to A square plus C square minus 2 CA cos B, and C square is equal to A square plus B square minus twice AB cos C. So let us try to prove one of the results. Other things will come similarly. Now let us draw the diagram again for the proof of cosine rule. Suppose this is the triangle ABC. In order to prove this result, I said there are various proofs, but I would like to give you the simple proof of it. So from the point A, you drop the perpendicular on the opposite side at say M. This angle is known to be B. If this is B and the total distance BC is small a, this opposite side is small c, this opposite side is what? Small b. Suppose the height of this triangle ABC, AM is equal to what? H. Now in this right angle triangle ABM, if I find cos B, it is BM upon hypotenuse is C. So this BM becomes C cos B. So this much distance is nothing but C cos B. So adjacent side of the angle B, I can write hypotenuse times cosine of the angle B. Now because this total distance BC is small a, one can write the distance MC as small a minus C cos B. So this much distance is known to be what? A minus C cos B. Now let us apply Pythagoras theorem for both the triangles. So in triangle ABM, I have C square is equal to, hypotenuse square is equal to H square plus C square cos square B. So this is in triangle ABM. What I have? C square is equal to H square plus C square cos square B. Similarly, in this right angle triangle AMC, B square is equal to H square plus A minus C into cos B bracket square. So in this right angle triangle, Pythagoras theorem is applied once again. Now what we do to establish this result, we will try to eliminate H by taking the subtraction. So if I get over here, this is what? Something C square minus B square is equal to minus, minus and minus. H square is cancelled. I get C square cos square B minus A minus C cos B bracket square. So I get C square minus B square equal to c square cos square b minus a minus c cos b bracket square is what? A square minus twice ac cos b plus c square cos square b. Now observe that this c square cos square b and minus c square cos square b is cancelled. And what is we are left with? C square minus b square is equal to minus a square minus minus plus twice ac cos b. So what we are proving essentially is this a square plus c square minus 2ac cos b is equal to b square. The result that I quoted after this, it was b square is equal to c square plus a square minus twice ca cos b. This result I have proved using this. So a square plus c square minus twice ac cos b is equal to b square. A square plus c square minus twice ac cos b is equal to b square. This result is being established. If I wanted to apply this, I would have taken ba here and the thing can be proved very easily. So if I choose this as a, this is b and this is c, the result a square is equal to b square plus c square minus 2bc cos a will come very easily. So this way we have proved the cosine rule. Now after proving this cosine rule, you know that whatever angle I consider in triangle ABC, whichever, it always lies between 0 and 180 degree. So as far as sine of the angle is concerned, sine A, sine B, sine C, they are always positive in triangle ABC. Whereas cos A, if A is obtuse angle, we know that cos A is negative. And whenever A is acute angle, cos A is positive. And whenever A is right angle, that time cos A becomes 0. So one can see one very important remark in this. So if I box this as a cosine rule, and if I make three cases regarding b square plus c square minus a square, because of this difference, I could have cos A either positive, negative or 0. Accordingly, what we get, let us discuss very quickly. So b square plus c square is equal to a square. If I choose, this numerator becomes 0 and hence cos A becomes 0, and cos A becomes 0 means A is right angle. Therefore, triangle becomes right angle triangle, and we see that the Pythagoras theorem is also satisfied. Being A hypotenuse, angle opposite to A is capital A, which is 90 degree. So Pythagoras theorem is satisfied over here whenever b square plus c square equal to a square, using what? The cosine rule. So this was the first remark. Second remark is, if b square plus c square is greater than a square, then this difference is positive. Already b and c are the sides, it is positive. So numerator is positive, denominator positive, so right hand side is positive. Therefore cos A is positive, and if cos A is positive, A has to be what? Acute. In this case, A is 90 degree. In this case, A is in between 0 and 90 degree. So whenever b square plus c square is greater than a square, your angle A is acute angle. Number 3, if b square plus c square is less than a square, means this is smaller than this, so difference is what? Negative. Negative upon some positive quantity is negative, so cos A is negative, therefore A has to be what? Obtuse. So I must say that here 90 degree is less than A is less than 180 degree. So everything depends on b square plus c square is equal to a square or greater than a square or less than a square to get about the angle A, whether it is acute obtuse or right angle. So b square plus c square equal to a square means a is right angle, b square plus c square greater than a square means a is acute angle, and b square plus c square is less than a square means a is obtuse angle. So these are the remarks of the cosine rule for testing whether the given angle of the triangle is acute, obtuse or right.